By 2050, the world's population is expected to soar to almost 10 billion people, and 2/3 of us will live in cities. Space will be at a premium. High-rise offers a solution, but concrete and steel, the materials we currently use to build high, have a large carbon footprint. An answer might lie in a natural material we've used for millennia.
Our view is that all buildings should be made of timber. We think that we should be looking at concrete and steel like we look at petrol and diesel.
I think it's very realistic to think that someone will build a wooden skyscraper in the coming years. There's a lot of potential that's unrealized for using timber at a very large scale.
Throughout history, buildings have been made of wood, but it has one major drawback. It acts as kindling. Fire has destroyed large swathes of some of the world's great cities. But by the early 20th century, the era of modern steelmaking had arrived. Steel was strong, could be molded into any shape, and used to reinforce concrete. It allowed architects to build higher than ever before. So why, after more than a century of concrete and steel, are some architects proposing a return to wood?
If concrete were to arrive as a new material on Dragon's Den, if you were to pitch it and say, I've got this brand new material, it's liquid, and you can pour it into any shape and it'll solidify, that sounds great. But then when you say, but we need a whole new fleet of trucks to move it around, and actually when it solidifies, it's not strong enough, we have to stick this other stuff in it called steel. I don't think it would be a compelling case.
Concrete and steel are costly to produce and heavy to transport. Wood, however, can be grown sustainably, and it's lighter than concrete. And crucially, as trees grow, they absorb carbon dioxide from the air, locking it into the timber. One study showed that using wood to construct a 125-meter skyscraper could reduce the building's carbon footprint by up to 75%. Regular timber isn't malleable like steel or concrete, and it isn't strong enough to build high. But engineers have come up with a solution. It's called cross-laminated timber, or CLT for short.
It's basically a new material, even though the underlying material is something we've used for millennia. It's cross-laminated, so the layers of wood are glued at 90 degrees to each other, and that makes for a very, very stable material.
CLT is light, and it's comparable in strength to concrete and steel. But how does it cope when burnt with a high heat source?
The charred wood is extremely insulating. That's the tree's natural protection against a forest fire. It chars, it loses some of its structural mass, but when you remove the source of flame, it extinguishes itself. When steel gets hot, it gets a bit softer. We've actually seen some steel roofs collapse in fires where wooden roofs have not.
London architects War Thistleton are already designing buildings with this new kind of timber.
There's a CLT building behind where the timber building sits behind timber-clad, and then there's a really simple galvanized steel walkway. Cross-laminated timber is a material that we work with a lot. Once these panels arrive on site, we're building, a floor a week, at least. So this is incredibly fast. This is maybe twice as fast as concrete. Because when you build a concrete building, what we call concrete buildings are actually floor slabs and columns. When we build a cross-laminated timber building, we're building floor slabs, all the external walls, all the internal walls, the lift cores, the stairs, the stair cores, everything's made of timber. So these are like honeycomb structures.
Andrew and his colleagues designed Britain's first high-rise wooden apartment block and have recently completed the world's largest timber-based building. Behind these bricks is a timber core made from more than 2,000 trees sourced from sustainable forests. And this London practice is not alone in advocating the use of CLT. Ambitious wooden high-rise buildings are also being constructed in Scandinavia, Central Europe, and North America. As yet, nobody has used CLT to build beyond 55 meters. But Michael Ramage's research centre in Cambridge, working with another London practice, has proposed a concept design of a 300-metre tower to be built on top of one of London's most iconic concrete structures, the the Barbican.
The way we've engineered the oak wood tower is to look at the global structure and is it stable and would it stand up? And we believe the answer is yes. The columns at the base of the oak wood tower would be about 2.5 meters square. So that's solid timber made of small elements glued together. I think we'll probably see incremental increases from the current height of about 50 meters. And at some point, someone will make a step change probably to about 100 meters.
Making that jump in height will be a difficult sell. The cost of building wooden skyscrapers is largely unknown, but those costs could be reduced by prefabricating large sections of buildings in factories. And city dwellers will need to be persuaded that CLT does not burn like ordinary wood. As an attractive natural material, wood is already popular for use in low buildings. If planners approve, it could rise to new heights.